You walk these streets every day. The concrete grid, the traffic's hum, the rhythm of the crowds. You assume it's all just a normal part of life. A messy product of history, economics, and human need. But what if it's not? What if your city is a program, a piece of code running on some massive, unseen machine? What if the roads, buildings, and subways are just the architecture for a simulation? And what if that simulation is starting to fail? It starts with the small things. The stuff you just brush off. That weird feeling of déjà vu when you see the same rare car twice in 5 minutes. A flicker in the corner of your eye that looks almost digital. These are the bugs, the cracks in the code. And they're getting more frequent, more obvious. People will tell you it's a trick of the light or a lapse in memory. But for anyone paying attention, they're warnings. The system is getting unstable. To really get what might be happening, you have to stop looking at your city as a place and start seeing it as a system. The idea that city planning looks like computer architecture isn't just a convenient metaphor. It's a strange and startling parallel. Fly over any modern city, and what do you see? A pattern. Rectangles connected by straight lines. Now, look at a microprocessor. It's the same pattern. The city blocks are transistors. The roads are the conducting paths. Is that a coincidence? Both systems are designed to manage complexity and move information. It turns out, the grid is just a super efficient way to arrange complex parts, whether they're buildings or memory chips. Your daily commute follows paths that aren't so different from the data buses on a motherboard. Shuffling people, goods, and energy, all forms of information from one node to another. Sure, the history books tell us this started with ancient cities like Mohenjo-Daro, praised for their practical, organized layout. But what if that origin story is a red herring? What if the grid wasn't designed for human convenience, but was implemented as the basic architecture for a simulation? A logical, repeatable framework to build a rendered reality on. In this view, the city isn't just like a computer. It is one. The concrete and steel are the hardware for a program designed to contain and observe us. And for centuries, it's been running just fine. But now the hardware is getting pushed to its limits, and the code is starting to fray. People call them glitches in the matrix, and it's become shorthand for those moments that just don't make sense. For a long time, they were just weird stories you'd hear on a podcast or in some corner of the internet. But now, with billions of cameras filming every second of our lives, the evidence is getting harder to just laugh off. Think about the stories you've heard. The person on a security camera who just vanishes. The row of parked cars, all identical, same license plate, as if the program just copy-pasted the same asset by mistake. Or witnesses reporting a whole crowd of people freezing in place for a few seconds, mid-stride, like someone hit a global pause button. Of course, skeptics have easy answers. The vanishing person, a corrupted video file. The duplicate cars, a wild, 1 in a billion coincidence. The frozen crowd, mass delusion or an elaborate prank. A helicopter's blades appearing to stand still is just the camera's frame rate syncing up. These are dismissed as optical illusions or failures of memory. But what if they're not? In video game design, these are called rendering anomalies. When a game engine gets stressed, it messes up. Objects duplicate, fail to load, or get stuck in animation loops. It's a sign the system is struggling to keep up. Now, think about our world. The amount of information being generated and captured is exploding. Every phone is a high-def camera. We're surrounded by them. Is it possible that our constant, collective observation is putting a new, unprecedented strain on the simulation's engine? What we call glitches might not be random. They could be the symptoms of a system hitting its processing limits, revealing the digital seams of our reality. The code is struggling to render everything, for everyone, all at once. And these little tears in the fabric are our first peek behind the curtain. If these patterns are starting to click for you, and you want to keep questioning the world around you, make sure to subscribe and hit the bell icon. You won't want to miss where we go from here. If the city is a program, its architecture has to be more than just buildings and roads. It has to be functional. The very components could be part of a massive, city-sized circuit board. This idea is starting to get weirdly close to our own real-world tech. For decades, computer chips were flat, 2D structures, a lot like our sprawling suburbs. But engineers hit a wall. Transistors couldn't get much smaller. The solution? Build up. In late 2025, a real collaboration between engineers from institutions like Stanford and MIT with Skywater Technology produced the first monolithic 3D chip in a commercial US foundry. This wasn't just stacking old chips. It was building a skyscraper of computation, with layers of logic and memory built right on top of each other. Vertical wiring acts like elevators, moving tons of data at incredible speeds. Tests showed these chips outperforming their 2D counterparts by a factor of 4. with simulations suggesting gains up to 12 times for complex AI. They're calling it a Manhattan of computing. Now look at a city skyline. We've been building vertically for a century, supposedly for economic reasons, but the parallel is just uncanny. We've been unconsciously mimicking the next step in computer architecture. But let's go deeper down the rabbit hole. What if the materials of our cities are part of the circuit? Think about granite and quartz, two of the most common minerals in the Earth's crust and key parts of our city foundations. These materials have a property called piezoelectricity. When you put mechanical stress on them, they generate an electrical charge. This is a real thing. Now apply that to a city. A metropolis is under constant stress and vibration. The rumble of subways, the weight of traffic, the footsteps of millions. Could the granite in our foundations be acting as a giant piezoelectric battery, converting the city's mechanical energy into the power needed to run our reality? This suggests the city itself might be a self-powering machine. And for a final, wild thought, look at the rose windows of Gothic cathedrals. Their intricate, geometric patterns have a strange resemblance to the cross-section of a magnetron, a device that generates microwaves. Could these stunning works of art also be serving a purpose we can't even begin to imagine? So why would these glitches be happening now? Why is the program failing after running smoothly for so long? One spooky possibility is a fun, if slightly inaccurate, analogy to a real principle in quantum physics: the observer effect. In the quantum world, the simple act of observing a particle actually changes its behavior. Reality at its most basic level seems to respond to being watched. Now, that's about tiny particles and scientific instruments, not our everyday world. But let's borrow the concept. For most of history, an event happened and then it was gone, living only in memory. Today, almost every moment is observed, recorded, and replayed by millions of digital eyes. What if our reality was designed to save processing power, like a video game that only renders the details the player is looking at? For millennia, this would have been a super efficient system. But with the explosion of cameras, drones, and live streaming, we're forcing the simulation to render almost everything, everywhere, all at once in HD. Are we, the observers, accidentally de-dicing our own reality? The system might be struggling to keep up, causing those rendering errors we call glitches. This leads us to philosopher Nick Bostrom's famous simulation argument. He argued that one of three things must be true. Civilizations like ours usually go extinct before reaching technological maturity. Mature civilizations don't care about running ancestor simulations, or we are almost certainly living in one. If we are, the question is why? A recent theory from physicist Melvin Vopson offers a wild idea. Gravity itself might be evidence of a simulation trying to run itself efficiently. The theory suggests gravity clumps matter together to reduce complexity and save processing power, like a cosmic zip file. If this is true, then every glitch might just be a side effect of the universe constantly trying to optimize itself. If your program is glitching, what do? You roll out a patch. A system upgrade. Look around you, it might already be happening. We call it the smart city. We're told it's all for our benefit, more efficiency, more convenience. We're covering our cities with IoT sensors, AI traffic management, and connected services. But look at it through the lens of this theory. A smart city is a system that is more deeply and efficiently coded. It monitors, tracks, and manages everything, including us, with incredible precision. It's an attempt to patch the bugs. This upgrade is happening at the same time our own tech is evolving to mirror it. The breakthrough in monolithic 3D chips isn't just about faster phones. It's creating hardware with the same architecture as a dense vertical city. The silicon skyscrapers are a perfect reflection of our own. The convergence is undeniable. We're building our tech in the image of our cities, just as our cities are being rebuilt to act like computers. Is this our own innovation? Or are we being guided by the simulation's architects? Are we, the users, being tricked into building a better, more robust version of our own prison? This system upgrade promises a seamless utopia. But it could also be a patch to fix the glitches, smooth over the cracks, and make sure the simulation can keep running without us ever noticing. So where does that leave us? We started with a wild idea. Your city isn't what it seems. That the concrete is code and the traffic is a machine's hum. We've seen how city layouts echo computer chips, how skyscrapers mirror the latest breakthroughs in 3D chip design, and how the glitches we dismiss might be rendering errors from a system pushed to its limit. We've even flirted with the idea that the very ground beneath our feet could be powering the whole thing. The choice is yours. You can write this all off as a fun thought experiment, a collection of coincidences and sci-fi tropes. Or you can start to pay attention. Look for the patterns, the repetitions, the moments that don't quite line up. The next time you walk down a familiar street, ask yourself, are you walking through a city, Or are you moving through a line of code? Have you ever experienced a glitch in the matrix? A moment that made you question everything? Share your story in the comments below. Let's see how deep this rabbit hole really goes.